let's get this lesson done because we have lost some of our time from going through the test. Notice that this lesson is called Solve Rational Equations and Inequalities. This is extremely similar to something that we have already done. And I'm just going to remind you. I'm going to give you x squared plus 2x minus 3 is greater than 0. This is called a polynomial inequality, and you learned how to solve these in this class. Now, if the question had said this, you would immediately know what to do to solve that. What would you do? You're going to factor. You're going to factor. Oh, mercy. Doesn't factor. Good. So what's x equal? Yeah. Now, if it had said this, then these are what we called critical numbers. And what we did was we took those critical numbers and we put them on a number line. Good. I thought you might. I thought you might. So we're going to put -3 and 1 on the number line. And we're going to pick a number in each of those sections that the number line has been broken into. Pick a number down here. Fine. Here?
0.
Thank you.
2.
And what we want to know is, do those numbers we wrote in red make this greater than 0 or not? Now remember, I don't care what the number is, I just want to know, is it bigger than 0 or not? If we let x equal -4, is this factor positive or negative? Negative times. So for those of you who are watching, I'm putting the -4 here. Class said that was negative. Put -4 here. Negative, thank you. So that's a negative times a negative, which is a positive. Is a positive number greater than 0? Yes. So I know that all the numbers from -infinity to -3 make this work, make this true. You remember doing this?
Yes.
All right. If x is 0, is this factor positive or negative? Positive. And a positive times a negative is a negative. Does a negative number make this inequality true or false? False. And 2. Positive or negative? Positive. A positive times a positive. Now, does a positive number make this inequality true or false? True. So, what makes this inequality true? Well, you said all the numbers from -infinity to -3. And from 1 to infinity. Why do I need to put parentheses with the -3 and with the 1? Good. Because it doesn't equal 0. Good. Guys, this is the idea behind what we're doing today. Right here. Okay. Are you thinking back to algebra? Okay. Okay, so let's go back up here. Now remember, the difference between what we did at the bottom and what we're doing now is that, oh my gosh, that's a rational function, not just a polynomial. I got variables in the denominator. The only thing that's different here is I just got to take care of the denominator the same way I'm taking care of the numerator. All right. Now, this is stuff we have done before also. Let's just take a look at the graph. Look at this graph right here. And we're going to try to answer this question. What does it mean graphically for a function to equal 0? The what? The y-axis? The x, it's right there. It's your x-intercept. Isn't it your x-intercept? Yeah, it's your x-intercept. So where in this case is my x-intercept? So you're going to write over here, you're going to write x equal -1. What about this one? What does it mean graphically for g of x to be positive? X values? Y values. Your graph's above the x-axis. Well, let's see, where's this graph above the x-axis? There. And there.
So from -infinity to
What about that hole? Oh, we haven't talked about that hole yet, have we? So we're going to say -infinity to where? To -3. Is -3 included or not? To -1. Now, is -1 included? No, because that would be equal to 0. Good. -1 to infinity? What? Is this right here?
Yeah, that's right.
And then, okay, so then, and then 1 to infinity? Yeah. 1 to infinity. Remember, we're just looking at where the graph is above the x-axis. What about the next one? Where the graph is below the x-axis. Where does that happen? -1 to where? Here's what I'm hearing. I'm hearing -1 to infinity, and I'm hearing -1 to 1. Which one is it? Because I got a vertical asymptote at x equals 1. And this graph does not go to x equal 1 nor past it. Parentheses or brackets? What about number 4? Graphically, what does that mean? Greater than or equal to 0? On or above. Good. On or above the x-axis. Where is this graph on or above the x-axis? Good. There you go. Good. Tell me if there's something you don't understand, okay? What about the last one? G of x is less than or equal to 0. Graphically, what does it mean? On or below the x-axis. Good. Where does on or below happen? So, is that right? Yeah, good. Good. In Algebra 2, you learned about asymptotes and holes. Do you remember what you learned? Oh, horizontal asymptotes are comparing the degrees of the numerator and denominator. Do you remember how that works? We're gonna review this, not today really, but we'll just talk it today. No, if the degree on the top is bigger than the degree on the bottom, there's no horizontal asymptote at all. If the degrees are the same, the leading coefficients. If the degree of the numerator is smaller than the degree of the denominator, it's y equals 0. Now again, we'll go through that in another lesson. What do you see about the degrees of the numerator and denominator here? They're the same, so the horizontal asymptote is They're coefficients. Y equals 1. Didn't? We'll get it this time. That's why your horizontal asymptotes y equal 1. Do you remember where vertical asymptotes come from? Yeah, because I want to know where is this thing undefined. And I have undefined when my denominator is 0. So I want you not only to factor the denominator, I want you to factor the numerator as well. What is it? When you have a common factor that factors out of the numerator and denominator, what does that tell you? You have a whole. And the whole is, at what x value does this equal 0? At what x value does x plus 3 equal 0? That's why you have a whole at x equal -3. How do you find the y value of the whole? I plug it into what? Into whatever I have left. And look what I have left. If I let x equal -3, what's -3 plus 1? What's -3 minus 1? Positive 1/2. So the coordinates of your whole are, that's where your whole is. Now, so I had a whole at x equal -3. Talk about this vertical asymptote. Where does it come from?
The 0, whatever gets to 0 is whatever you have left in the denominator.
Right. After I factor and divide out any common factors, it's whatever makes the remaining denominator equal 0. So x equal 1 is where your vertical asymptote is. Again, we will address this in much more depth later. You're welcome. The goal of this lesson is to learn how to solve these using algebra instead of having to look at a graph. Have we? We did with polynomials, just not with a rational function, not with a denominator. The process, though, is exactly the same.
Teachers, please pardon an interruption, but you have not dismissed the baseball team for the game this afternoon.
Now we're going to go through this one fairly quickly. Given the function g of x, this is the same function that we had graphed. Find out what g of -3 is and what g of 1 is. Now here's what I would encourage you. I would encourage you to put them right here. We want to find g of -3, right? You could put it in here. But you could also put it here, because those are the same thing, right? So it doesn't matter where you put them, one or the other. You can't put them here because this is different. You can't put it in here because we don't have the x plus 3's anymore. What's g of -3 going to give you? Well, tell me specifically. What will you get what over what? If x is -3, I get 0 over 0. I get 0 over 0. Now, yes, that sucker's undefined, but I need specific. You get 0 over 0. What's g of 1? It is going to be undefined, but again, specifics. What's the numerator? What's the denominator? 8 over 0. What did we have at x equal -3 on that graph? We had a whole. Ladies and gentlemen, anytime you get 0 divided by 0, when you plug in a number, That's screaming to you that you have a hole. Anytime that you have a non-zero number divided by 0, you have a vertical asymptote. Yep. Anytime you have 0 over 0, that screams to you that you have a hole. If you have a non-zero number divided by 0, that screams that you have a vertical asymptote. We just answered this question right here. All right. Completely factor that function. We did that at the top, didn't we? Now, so I don't have to scroll back and forth. What did we have? X plus 3 times x plus 1 over x plus 3 times x minus 1. Identify the values of x that make the function equal 0 and the values of x that make the function undefined. Let's start with the undefined first. Let me do it this way. When does a fraction equal 0? When the numerator is 0. Now, here's where you got to be careful. Can we say -3 here? No. No, because the thing's undefined there, isn't it?
Yep.
So -3 is not going to give you a 0. -1 will, though. You always factor those common factors out first. Yes. Because your zeros are going to come from what's left. Now, you have seen did you lose something?
I just.
Okay. You've had notes in the past that looked like this page, where we had Sparks gives you steps.
Yeah.
And I'm gonna, We're not gonna ignore them completely. We're gonna do the steps this time on the first one. To solve rational inequalities, the process to follow is identical to the process that we learned to solve polynomial inequalities, except now we got to deal with the denominator. That's the only difference. All right. We're still going to work with that same daggum equation. Step 1. Back. Well, if we don't have that memorized by now, we got a problem. And I don't want to do it there because I don't have enough room. X plus 3 times x plus 1 over x plus 3 times x minus 1 is less than or equal to 0. Now, you know this, correct? All right, look at step 2. It says set each factor equal to 0. When we do this, what we are finding is our critical numbers. Every factor that you see, we're going to set equal to 0. And those are our critical numbers. What's our critical number here? -3, -1, another -3, and 1. So -3 and plus and minus 1. So far, so good? Now, draw a number line that's divided into segments using those zeros. Go to our number line. -3, -1, and 1. Now we're on step 3. Choose a number from each interval. Pick. And determine the sign of each factor of the rational expression based on that chosen value. So what we're going to do now is we're going to take those numbers I wrote in blue and we're going to put into the whole thing. All right? Now, I really don't need to have those marked out. X plus 3, x minus x plus 3. If x is negative 4, now what I'm going to do is I want to know positive or negative, positive or negative, positive or negative, positive or negative. That's what I want to know. If x is negative 4, negative times a negative over negative times negative. When you do all that mess, positive over positive. What about when x is negative 2? Positive. When x is negative 2? Negative, so I got a positive times a negative on the top. When x is negative 2, negative times a negative. So I get a negative over a did I mess up on something? Oh, sorry. You're right. You're right. So what have I got here? Okay. Yeah, you got to catch me when I screw up because I'm good at it. 0. 0. Positive and a positive. Positive, negative. One more. When x is 2, let me find another color. I'm out. When x is 2, positive, 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 positive. I'm pretty positive that's a positive. Yep, so positive. Now, let's talk about the critical numbers. What do each of those critical numbers do? If x is negative 3, undefined, so is undefined less than or equal to 0? Because you know that x equal negative 3 is undefined. Okay, so we know negative 3 is not going to be an answer because I'm wanting you to check. Negative 1. If x is negative 1, no fiddle. If x is negative 1, what's the top? If x is negative 1, 0 over negative 2. What's 0 divided by negative 2? Is 0 less than or equal to 0?
Yes.
You betcha. Negative 1 works. What about x equal 1? Does it? If x is 1, then that would give me 4 times 2, right? Over 5 times
0.
What's that? That's undefined. That doesn't work either. The only times I'm checking those critical numbers is when I have the or equal to 0, because I want to know if I'm going to have to use brackets or parentheses. What's our answer then? Remember, I'm looking for this. So I'm only looking for this one, right? Okay, Malin said bracket because -1 is included. To where? Included or no? No. Unincluded. Yeah, we'll take that. Unincluded. Excluded. Does that make sense graphically? Because graphically, oh, I lost it. Graphically, what does less than or equal to 0 mean? On or below the x-axis? Is this graph under or on the x-axis? From there to there, including -1, but not including 1?
Yes.
You betcha. You betcha. Oh, sakes. Okay, we got 11 minutes. I want us to do this one. There are 3 on the, oh, snap. We're not going to do this one. Go to the back page. What I want us to do is this one right here. And this one right here. No. Okay, step 1. Factor. Okay, factor. Oh. What's wrong with that denominator? That denominator doesn't factor. So we have 2 choices. We can use quadratic formula or we can use complete the square.
Complete the square.
We're going to complete the square just to remind you, and I think completing the square is easier on this one. If your leading coefficient is 1 and that middle term is even, completing the square is real easy. If you say, I hate it, fine, go ahead and do quadratic formula. It's not a problem. I want to know when x squared plus 4x plus 2 is equal to 0. Do you remember when you complete a square, you put the constant on the other side? To figure out how to complete the square, I half that and then I square it. You remember? I get 4. Good. But if I've put the correct number here, then this will factor into something times itself. Equals. And if I take the square root of both sides, equals what? Plus or minus the square root of 2. These are my critical numbers. Well, snap, I don't know how to put those on a number line. Don't know what they are. That's when you go to your calculator and you will type in -2 plus root 2, and you will type in -2 minus root 2. You hear me? Now, don't see many calculators. Let me just tell you what the answers to that are because of time. The answers to that are -0.586 and -3.414.
So would 3 also be okay?
Yes, and we'll take care of that in just a second, but yes. So our critical numbers are x equals those 2 numbers that I just wrote down, plus, as Maribel said, where is that numerator equal to 0? At 3. So 3 and Oh, that's not what I wanted. Do you know how to finish? Yeah? Like you really do know how to finish? What's the next step you're going to take? You're going to find a number in each of those regions. Give me some. Fine, -1, -2, and 4. Now, you're going to, okay, you're going to, yeah. Remember, you're going to test these green numbers, and you're going to test those green numbers in here, right? And you're going to determine if you get positive or negative. Those critical numbers, do any of those critical numbers make this expression equal to 0? So 3 is going to be part of your answer. Will the other two critical numbers be a part of your answer? No, because they made the denominator 0. Correct. You with me there? Okay. I'm sorry. Both of these numbers will be excluded. You will have parentheses because those numbers make the denominator equal to 0, which means those numbers make that expression undefined. We set that equal to 0, and we used the complete the square, and that's how we found them. I want to go through this one, at least get it started. How is this one different from all the other ones we've done? That one's not set equal to 0. Yeah, I've got two different fractions, and in all the other ones, they're set equal to 0. I can make this one be set equal to 0, though. What if I subtracted this one? Now it's set equal to 0. Yeah, because you have to get one fraction over here on the left, and the only way to do that is to get a common denominator. So let's get that part done. Oh, sorry. No. It's not equal. The sign stayed the same. Thank you for that catch. What's our common denominator? X plus 2 times x minus 1. I don't know how you did this before, like in Algebra 2. Do you want to just multiply each piece by what it's missing? Is that what you want to do? So this is missing x minus 1. This one's missing x plus 1. And this one's missing all of it. But what do I get when I multiply that anyway? I'm still going to get 0, so I'm not going to worry about it. Are you with me here? So that numerator, I got 3x minus 1 minus 2x minus 2. Oh, well, snap. What's the matter with me? 3x minus 3, thank you. What did I do wrong now? I didn't do anything wrong, did I? What did I do? 3. Oh, crap. Sorry if you're watching the video. Is that better? Is that better? Okay. Now, seemingly Christmas. X minus 7 over x plus 2 times x minus 1. Now, can you finish it? Okay. What are your critical numbers going to be? 7, negative 2, and 1. And I'm not going to do it anymore because I'm going to screw something else up. Just watch your steps. You know how to do this.